It's been a record year for heat early in the riding season, but for its entire production run, one of the complaints owners of the Honda ST1300 PanEuropean have had is the amount of heat this big V4 produces. In typically cooler climates like mine, this has never been too much of an issue. But as Bob Dylan would say,
"Oh, the times they are a-changing."
Today we make a series of modifications to our Honda ST1300 to help reduce the amount of heat the rider feels while riding in stop-and-go traffic or at a stoplight. Then we measure the effect on the engine and exhaust system to see just how well they worked.
In my previous video on ST1300 performance mods, I discussed a number of things I did to make the bike perform better and as a consequence reduce the ambient heat around the engine. One of these modifications involved bypassing the pulse secondary air injection system, or as it's commonly referred to, the PAIR valve. If you haven't already seen this video, click over and watch it since I'm not going to go through much of an explanation here. What I will tell you is the bike's exhaust smells richer at idle since bypassing the PAIR, but I will continue to experiment going forward. A richer mixture will lower exhaust gas temperature. Just know that with all the modifications you're about to see, this motorcycle's PAIR valve has been bypassed. I see a lot of questions regarding the ST1300's heat in forums, and up until I recently purchased my third ST did I actually reflect on that. You see, the ST1300 was the bike that made me go from riding a Harley-Davidson touring to riding a sport touring back in 2008. I'll elaborate on that in some future video, but for now my point is, coming off an air oil cooled large displacement Harley, the heat just wasn't noticeable, or it was what I would have perceived at the time as normal. Fast forward to 2021, and after riding numerous BMWs, Ducatis, Kawasaki's, Triumphs, yeah, okay, now I can feel it.
Firstly, let's make one thing a little bit clearer. The rider of the ST1300 feels heat primarily under the seat, not because there's something under there getting hot, but rather this is the gathering point and collection area for heat that's being channeled off of the big V4 engine and the exhaust system. Under the seat on the ST1300 is the primary fuel tank, which obviously can't get too hot because it's full of fuel.
The heat the rider is feeling under the seat is being generated from two key sources. Obviously the engine itself. I mean, you sit just to the rear of this big flying V brick of aluminum that wants to shed as much heat as possible that's being generated from combustion. There is not much we can do about the actual heat coming off the engine block. There are some aftermarket shields you can buy to try to deflect some of the heat, and some riders resort to aluminum tape on the bottom of their seat pan. Not really sure how that works. The ST1300 is equipped with a relatively thick rubber heat shield that drapes over the back of the engine, but in reality rubber will only last so long, and it tends to also retain a lot of heat that you put into it, rather than just reflect it.
If you really want some suggestions on how to block that engine heat from roasting your personal marshmallows, then I suggest you make sure that your seat is at least in the middle height position, or if you can tolerate it, even higher. And if not, or even better yet, you can always do this.
Seriously, people much smarter than you and I have known for centuries that sheepskin is comfortable, warm in the cold, and cool in the heat, and will make those marshmallows of yours feel like they're on a big fluffy cloud the next time you venture down the highway. The real reason we are here today is to deal with the radiating heat that we can help manage, and that heat is being generated by the motorcycle's exhaust. The ST1300 and 1100 for that matter have this long sweeping dual pipe header that is on each side of the bike. The exhaust then runs down the length of the engine and transmission to the swing arm, where it sweeps up into the muffler. Now take a look at how well the fairings hide these exhaust headers. You would not know they are there, and herein lies the first problem. There is so much header pipe on the ST that it holds a lot of exhaust heat right beside the engine. Take a look at a typical inline-4 engine. The exhaust headers are routed to the bottom of the engine in a direct line. not this flowing, sweeping, inverted S-curve that adds more hot exhaust pipe back and forth along the side of the engine. And even when you get to the collector pipe, it's sitting right beside your foot peg. So the first heat control measure we are going to do is wrap up these exhaust header pipes, just down to the bottom of the header where it's exposed to the air under the motorcycle. Wrapping up exhaust headers can take a little practice. If you're not happy with the length or look, unwrap and start again. I'm using a 1-inch wide design engineering exhaust wrap, the kind you'd find on Amazon or eBay or at your local parts store. I'm also not wetting the exhaust wrap before applying. Most guys soak the wrap in a bucket. You're not supposed to do that. You're just supposed to dampen it to help make the wrap a bit tighter. Being only 1 inch wide, I found I could get the wrap tight enough without making the wrap wet. I think there's a lot more mess when you do that. Now the fibers that are in the wrap are a bit itchy. They're like fiberglass insulation, so be aware. I used exactly 25 feet of wrap on each side of the motorcycle, and this 50 feet roll cost me $50 with tax and shipping. When wrapping the pipes, you want at least 1/4 inch of overlap from one wrap to the next. This is to prevent water and dirt from getting under the wrapping material. Keep your wrap tight and be patient. Wrapping where the pipes are tight on the Honda ST can be a little trying, so just take your time and stay focused. I'm also using hose clamps to secure the ends of the wrap. You can use stainless steel ties like the kind you use on CV boots, which again are available at any automotive parts store. If you get those, see if they also have this special tool that you can rent to secure them, because they have this tool to cinch and fasten them. I'm happy using automotive grade threaded hose clamps. The first few times you start the bike after installing the header wrap, make sure there is plenty of ventilation because it's going to stink and smoke pretty good. The wrap is curing around the pipe, and it's going to be noticeable until your first good ride where you get them hot for an extended period of time. Next, we're changing out the biggest culprit for exhaust heat on the ST1300, the factory mufflers. I've chosen a set of Delkevic performance mufflers because I've used them on a variety of bikes, including my first ST1300, and have found them to be a tremendous value. Nice and throaty and exhaust note. If you're concerned about noise of the aftermarket exhaust and you haven't watched my previous video on the ST1300 performance mods, then you just need to do that. If you have and you're still concerned about noise levels, leave the baffles that come already installed in the Delkevic mufflers in place, or just stick to your factory mufflers, but you won't see the dramatic impact on heat management if you don't put a free-flowing aftermarket exhaust on the bike. The Delkevic mufflers don't restrict the exhaust flow and don't have a catalytic converter in them. They weigh less than half the weight of the stock mufflers and sound great for safety's sake. Now that we've finished half the bike with exhaust wrap and performance muffler, I'm going to stop there and see how much of a difference it makes to our heat problem. So to clarify, the left side of the bike has the header wrap and the new Delkevic muffler, while the right side is stock exhaust and no wrap. I will point out that the Honda has a crossover pipe between the two sides of the exhaust, right around where the swing arm starts. With the free-flowing muffler of the Delkevic, any back pressure from the stock muffler will allow more exhaust to travel back through the Delkevic side at this point. I took initial cold temperature readings of the bike using my digital laser heat gun. The readings are in degrees Celsius, so bear with me if you prefer Fahrenheit. I'll subtitle those numbers in. Over a period of 15 minutes, I'll measure the difference in temperature from one side of the bike to the other. The bike is in the garage, under cover from direct sunlight and wind, and it is close to midday with the ambient temperature around 28 or 29 Celsius. I picked 6 points along the side of the bike to measure the heat changes. Front of the cylinder head, the number 1 and 2 header pipe about an inch down from the cylinder head, the number 3 and 4 header pipes in the same location, the rear of the cylinder head, the exhaust header collector, which is right by the rider foot peg on each side, and finally the top of the muffler under the saddlebag. Initial readings when the bike was cold was very close to ambient. Now I started the bike and the clock, and just to ensure we weren't favoring the side of the bike with the modifications, I always started measuring temperatures on the right side, which was all still stock. After 5 minutes on high idle, the bike warmed up. There was a 30-degree difference in temperature at the front 2 cylinders from the wrap pipe to the non-wrap pipe. Most surprising, though, was the over 70-degree difference at the header collector, which is right by the foot pegs. The left side of the bike with the wrapped header pipe and Delkevic exhaust was significantly cooler. After 10 minutes, the bike has settled the idle down, so some of the exhaust temperature actually decreased slightly, and the bare header was the same or even slightly cooler on one measurement than the wrapped header was. The collector area, however, showed the same 70-degree cooler temperature on the wrapped side. I'm going to point out that my theory on measuring the cylinder head temperature was probably flawed. As the thermostat on the bike opened and closed, coolant was circulated through the cylinder head, which gave me fluctuating readings. But what I observed is that there was little to no difference between the two cylinder heads as far as temperature throughout the test. So we're just going to drop these readings to simplify the data. Now for the last 60 seconds of the test, I took the bike to 3,500 to 4,000 RPM and held it there while the clock closed in on 15 minutes. At this time, I took my last readings. The exhaust headers were 100 degrees Celsius different from the wrap pipes on the left to the bare ones on the right. That's 212 degrees Fahrenheit. The collector beside the right foot peg was over 80 degrees hotter, while the muffler temperature on the right side stayed very similar to the Delkevic. So there's no fear putting too much heat under the saddlebags by using the aftermarket exhaust. So to summarize, there is a noticeable and real temperature difference when making these modifications. I believe the temperature difference between the wrapped header will only be more significant as more heat is poured through them, since the temperature of the wrap pipe seems to stabilize at around 265 degrees Celsius, while the unwrapped header shot up in temperature when fuel was put to the fire. The free-flowing Delkevic exhaust also played a significant role in the header pipe temperature, since a lot of heat can be felt coming off the collector pipe when holding the bike at a stop or moving slowly in traffic. This pipe is right by your foot and leg. By allowing exhaust gases to travel through and out, the pipe does not get as hot as the stock muffler side, further reducing rider discomfort. On a final note, after removing the Delkevic exhaust baffles, there was another 32% decrease in temperature at the 10-minute interval for the muffler, a 7% decrease at the header pipe, and an 8% decrease in temperature at the collector pipe. So, to get even cooler, be sure to remove the baffles from your aftermarket exhaust.
So what are your thoughts on making these modifications to your own ST1300?
More performance details I made to this ST1300, as well as all the fun I had working on the ST from start to finish, can be found on our channel, so be sure to check those videos out if you missed any. Finally, over the past few weeks, I picked up another little project, one that several viewers have been clamoring about, and certainly it is one of the most popular bikes around. Well, on my channel anyway.
If you figured out what bike I'm talking about from the few pictures that you've seen, make sure to put your answer in the comments below. Now, I'm gonna need the make, the model, and the approximate year since this bike was built for decades. I'll take the correct answer and draw for a $100 gift card from Fortnite if you live in Canada, Revzilla if you're from the United States, or if you live in the UK or Europe, we'll go with Fowler's Spares. For those of you outside Canada, this is still a Canadian dollar equivalent, since I'm paying for this out of my own pocket and I have yet to be monetized by YouTube. So to double your chances of winning, make sure you're a subscriber to Rod, Rides, and Wrenches. Good luck on the contest, and until our next video, be sure to ride safe.